Hey guys, this is Gavin once again, and I have got something special for you. As I promised in the previous video, that we'll be looking at logarithms. Right? Logarithms are basically a simple, I would say, a simple way of solving calculations or doing some calculations, because there's some numbers where you have indices and it's really hard to use any other method rather than logs. So logarithms, first of all, they were invited around 1550 to 1617, I believe. 1617, by a Scottish mathematician, physicist, and astronomer as well. His name was John Napier. So John Napier is the one who actually invented logs, right? Invented the logs, and apparently also invented the decimal numbers. So yeah, that's John Napier. The other thing, very important, is to understand where is logs defined. So logs are defined for positive numbers, right? For positive integers. And with that, let's look at the actual denotation of logs itself, right? So basically, this is how it's written: logs base a x equals y. However, how do we read this? The way you read this is logs of x to the base of a is the power of a, which equals to x, right? So basically it's saying it's log of base, which a is a base in this case, base x equals y. So logs of x, depending on what base is equal to y if and only if x is equal to a to the power of y, right? Now notice that here they precise the domain. So a has to be greater than 0 and x has to be greater than 0. This means logs are only positive, are always positive, right? So the value could be log of anything. It doesn't necessarily mean that the value is valid. The final number has to be positive, but the domain, before you start that, you need to start with positive numbers. So that's why you have your base has to be positive, right? Obviously your base has to be positive, and this number here has to be positive as well. So that's one thing. Let's look at an example and see if everything makes sense, right? And there are some useful equations on this. Now, with the first one, you have got log of 16 to the base of 4 equals to what? Now, it's crucial to know how to read this, because we'll give you an idea on how to solve them. So basically what we are after here, we want a number that we could raise 4 to get 64, right? So we want a number, basically here, we want a number that we could write. So we want, let's say, we want 64, right? 64 to equal, or 64 to equal 4 to some x, right? 4 to some x. So this is basically what we want. Whenever they write the log base 4, the base could change. Whenever the base has to be this way. So 64 equals to 1, and basically that's what we said here, right? Now how do we work out this? The way you would solve for this is basically think, what number can we raise to the power? What number can we raise to the 4 to get 64? Right? The only option really that you have is maybe try to convert this to make the base be the same, right? Remember in the previous video I said change the base to make them the same, right? So the way you change the base to be the same, basically we know that 64 is the same as 4 cubed equals 4 to the x, and therefore our x, right? Our x in this case, we could equate the base, and therefore we have x equals 3. Now this means log 16 to the base of 4 is equal to 3, right? 3 is our solution, guys. So, and this is how we actually work out the solution, right? So I hope this notation and everything is clear, but I'm gonna do one more example before we finish, and yeah, let's do it. Yeah. Right, so we're going to grab off that. What's the question? So the question is log base 25 of 125 is equal to what? So now this is the question. Again, let's analyze, identify. Let's change the question itself. Right? So we want, basically what we want y such that so we want y such that 125 is equal to 25 to the power of y. Right? That's what we want. But how do we get what we want? Right? This is the question. How do you get what we want? Okay, so the way you solve this, you have to analyze two things. Now, in the first step, I'm gonna rub off this. Right, in the first place, analyze what we have in this equation. We have both these 125 and 25. Right? Can we do something about them? Yes, we can. We can surely do something. Right? What can we do? What we can do is basically change the base. Even that the base are not the same, let's try to force the base. Let's have at least the lowest base possible that they have, right? Both of them. So that base have to be the same, right? The lowest base that we could get. Let's change 125. So we know 125, right? I'm gonna write this 25 and 25 to the y, right? So 125 could be written as 5 to the power of 3 or 5 cubed, and the 25, I know that 25 could be written as 5 squared. It should give me y, but this is also the same as 5 to the power of 2y. Why? Because the power of a power, you just have 2 times those 2 powers. Now the base is the same. Now the base is the same. Given that the bases are the same at this step, what we can do, we are allowed to equate the power, right? So what we can then have is x must be equal to 2y. Right? Now let's solve for y. Solving for y, we want y such that. Now, sorry guys, this is not x, this is 3. So this is 3. Now we're solving for y. We want y such that 125 equals to